Hello everyone, myself Dr. Vivek Kumar, Professor, Himalayan School of Biosciences, Swami Rama Himalayan University, Jolly Grant, Dehradun. I am again with you, new topic on endophytes, that is endophytes direct benefit to the host plant. In the previous lecture, we have discussed the endophytes indirect benefit to the host plant. So, as we have discussed before, the endophytes is any microbe that inhabits internal tissues of the plant without causing disease. So, all or most plants possess endophytes, and in most cases endophytes are seed transmitted and begin to promote growth and plant health as soon as seed germinate. Other endophytes may be recruited from the soil, but similarly they benefit the host plant. So, endophytic microbes are important components of the plants and they function in the following ways. They increase nutrients acquired by the plant, they defend plants from pathogens and insects, they increase stress tolerance in the plants, or we can say they mitigate the stress tolerance, they mitigate the effect of the stresses. They also modulate the plant development and suppress the weed growth. If we discuss the nutrient transfer, the endophytes bring nutrients to the plant, include those that fix atmospheric nitrogen in the plant tissues. So, once any diazotrophic endophyte inside the plant, so obviously if it is fixing nitrogen, then that nitrogen will be utilized by the host plant. So, these type of endophytes they include actinorhizal and rhizobial symbiosis. So, because of sensitivity of nitrogen is to the oxygen, we understand that nitrogen enzyme is oxygen sensitive enzyme. So, a few families of plants that engage in nitrogen fixing symbiosis, they sequester microbes in low oxygen nodules where nitrogen is fixed and transferred to the root tissues. Another type of nutritional endophytic symbiosis involves microbes that inhabit both endophytic tissues and extend out into the soil. So, once they are present in the endophytic tissues, then obviously they produce certain secondary metabolites utilized by the host plant, which enhances the plant growth. The various root endophytic could fix nitrogen, for example, Azorchus species, Acetobacter diazotrophicus, Herbaspilum species. The nitrogen fixation improves host plant fitness mostly in poor nitrogen environments. Endophytic strain Pinobacillus isolated from a poplar tree convert the fixed nitrogen to the pool of total nitrogen of the host plant as well as induce changes in the plant metabolism. So, this picture shows the application of bacterial endophytes. They play a role in nitrogen fixation, they play a role in plant growth promotion, and they secrete secondary metabolites, and these secondary metabolites they act as biocontrol agents. They solubilize phosphate also, and they also secrete the low molecular weight organic compounds which chelates metals, especially your iron, zinc, etc. So, if we discuss the plant growth promoting activity of the endophytes, the endophytic microbes play a critical role in plants adaptation to stress conditions and varying environments which can limit their development and growth. So, to contract with extreme environments, plants may form network with the microorganisms with the symbiotic relationship, conferring helpful effects on evolution of both partners and appropriateness. The extreme environment conditions, low water, nutrient availability, high radiation, strong winds, low temperature, all these factors affect plant survival and their organization. So, the endophytes they enhance plant growth through their ability to synthesize enzymes and by producing diverse bioactive metabolites, and especially the endophytic fungi especially such as Cibacina vermifera, Pyrimophora indica and numerous species of Coletotrichum and Penicillium, they are distinguished to have better plant growth promoting effects on their host plants under unfavorable conditions. So, the main activities of plant growth promoting endophytes PGPE, they are accompanied with hormone synthesis such as indole 3-acetic acid also known as IAA, cytokinins, gibberellins, they produce siderophores, they have the potential to solubilize phosphate, so they take up the nutrient and they also show biocontrol effect against the phytopathogens. So, the PGPE they can induce chemical or physical changes related to plant protection, a process signified as induced systemic resistance ISR. So, several reports have confirmed that the critical roles of plant growth promoting endophytic fungi in increasing tolerance against diverse stresses, heat, drought, salinity, low temperature and diverse heavy metals. Now, this picture shows endophytic fungi how they promote the host growth. The endophytic fungi, they act as biocontrol agent. They uptake nutrient and then mobilize the nutrient to the plant inside the plant root, and they also enhance the plant growth, resulting in increased biomass, increased lateral root growth and phytohormone stimulation. So, IA is a fundamental plant growth hormone for the use for the development and growth of shoot and root cells of the plants. So, there are many microbes including PGP, they produce indolacetic acid. Soil microbes, bacteria and fungi synthesize plant growth promoting compounds such as gibberellins and indolacetic acid. Several reports proved that endophytic actinobacteria, they synthesize plant growth regulators such as auxins, cytokines, gibberellins, gibberellic acid and IA in vitro conditions. Now, biocontrol agents, certain endophytes, when they produce, they show antibiosis, when they produce volatile organic compounds. So, they are considered as biocontrol agents or biological control agents. So, fungi play a critical role in controlling insect herbivores, not only in grasses but also in coniferous trees. Beauveria bassiana, an endophytic fungi known as an entomopathogen, it has been used to control the borer insect in sorghum. Bacillus subtilis, isolated from Spankisia, has an antagonistic effect in vitro against the pathogen Botrytis cinerea, which is responsible for rotting disease of tomato fruits. New endophytes such as Burkholderia, Pyrocenia and Bacillus cepaceae, they were used in biocontrol study against popular canker disease. The studies conducted, they have suggested that the endophytes, it could be bacteria, it could be fungi, they provide defense to host plants against pathogens and other pests, beginning at seed germination stage, lasting the life of the plant. So, bacterial endophytes such as Pseudomonas, including Pseudomonas aeruginosa, fluorescens, they produce a diversity of antifungal compounds, including phenazine 1-carboxylic acid, 2,4-diacyl-phosphoglucosanol, pyrrolinitrine, polyuterin and volatile like hydrogen cyanide that significantly inhibit the growth of the diverse fungal pathogens. The Bacillus species, they are considered important biological agents. They synthesize a variety of biologically active molecules that are potential inhibitors of the phytopathogens. Variety of lipopeptides that they produce include leakage in fungal hyphal membranes that greatly reduces their virulence as pathogen of the plant. So, all these things, they result in quorum quenching. Quorum quenching, that it affects where pathogenic fungi remain avirulent rather than the causing disease. So, the quorum quenching effects, we can say it reduces the effect of the pathogens. So, many of the antifungal compounds produced by endophytes, they target members of the fungi, that inducing nutrient leakage, resulting in reduced virulence of the phytopathogenic fungi. So, endophyte mediated anti-herbivory. So, some endophytes, they produce and fill plants with compounds that reduce herbivory by insects and other herbivores. The species of fungal endophytes in genus Epicloe intracellularly inhabit aerial parts of the plant, inside the leaves, seeds, and they produce a variety of alkaloids that deter feeding by herbivores. So, these alkaloids, they provide a bitter taste. So, once the herbivores, they try to chew the leaves, because of the presence of these alkaloids, they do not like the taste, hence the plant is saved. So, these endophytes have found application in increasing pest tolerance in commercial forage and turf grasses. However, the endophytes of this group of organisms are limited to grasses and sedges. Fungal endophytes of genus Periglandula in the morning glory have been shown to produce ergot alkaloids that make morning glories highly toxic to herbivores. Similarly, in plants community referred as locoweeds in the family belongs to the family Fabaceae, endophytic fungi in the genus Undiphyllum produce the toxic alkaloid swinesonine, a powerful anti-herbivore compound and a toxin also. And then there are certain stress responsive hormones. So, 3 phytohormone commonly associated with the range of stress response, they can be collectively termed as the stress response hormone, abscisic acid, salicylic acid and jasmonic acid. The phytohormone abscisic acid is commonly known as the plant stress hormone, which is involved in major signaling pathways, involved in biotic stress response, as well as being responsible for general plant growth outside of the stress conditions. Under drought stress conditions, abscisic acid is produced rapidly by plants to aid in the plant survival and in the suboptimal conditions. The enhanced level of ABA stimulates stomatal closure, though through H2O2 production in order to preserve the moisture, as well as the ABA production decreasing the lateral root growth, increase vertical root elongation to vitally improve water uptake and accelerate the senescence. The endophytic microorganisms have been reported to alter plant response to drought and can be used as an alternative and rapid way to enhance crop productivity. So, under water deficient conditions, endophytes, they colonize the rhizosphere and promote plant growth and develop through the variety of mechanisms. Endophytes can produce plant hormones that promote plant growth and development. Endophytic actinobacteria, streptomyces, olivaceous enhance wheat growth via oxygen production under drought conditions. Azospirillum brasiliensis, it improved in one report improved the drought tolerance in Arabidopsis by increasing ABA levels, and endophyte facilitated drought tolerance via alternation of hormonal profile has been reported in soybean, wheat, cucumber and other plants. So, this picture shows that the drought and salinity stress has been mitigated with the help of the endophytes, because they produce certain phytohormones. Finally, if we discuss the keywords, so the microbial endophytes and soil microbes, they could be employed to improve plant growth, to improve the plant health, and they enhance productivity directly in commercial crop plants. It could be your any variety, your wheat, your maize, your millets, etc., all seed crops. Benefits could also be realized when endophytes reduce pathogens. So, here they act as biocontrol agents because they prevent insect damage and they compete with the woody plants. Endophytes also help cultivate crops with less fertilizers. It means they are being used as biofertilizer because they can fix nitrogen, they can solubilize phosphate, they can enhance the growth of the plant, they can also prevent the growth of phytopathogens, and they using, if we are using endophytes, then less fertilizer, less fungicides, insecticides, herbicides, they are less used. So, obviously, the use of endophytes is environment friendly as well as the cost effective. So, in the future, we envision a change in practice to focus more on the optimization of relationships of plants to soil microbes and endophytes. If we use endophytes, potential endophytes which are having plant growth promoting attributes as a bioinoculants, definitely they will enhance the growth of plant, host plant, and that will be a step towards the organic farming. See you in next lecture. Thank you so much.